So what is it that our cluster looks like? We essentially support, in fact, first of all, we just support straight up Spark, right? It's 100% compatible with Spark. So if you just wanted to say, I just want to run exactly the way Spark runs today, you can do so. But the more interesting to get our value added features, we support two modes. One is called the unified cluster mode, and the second is called the split cluster. Or you could look at it as saying one is a mode in which the store itself is embedded. The second looks like much more standard Spark, right? Saying, hey, the store is actually isolated in a separate cluster than the Spark executors. Because depending on the workload, I might need either or both of these deployment topologies. So when you're running the store inside, what that essentially means is we are sharing the state. I mean, essentially, we work very closely with the Spark's block manager. For those of you know how Spark works, essentially, if you take RDDs or data frames, they're nothing but views, right? There is really no data being saved at all in Spark. It's just a computational engine, data just flowing through in some sense. But if you do a persist or a .cache inside of Spark, it lands up creating data sets in blocks. So the way we do things is that we work very closely with the block manager, and we also expose all our data sets, even though they are exposed as tables, if you may, from a SQL parlance, it's also exposed as RDDs or data frames. And we do it with zero copying, right? So that it's essentially reference-based access to the data sets. And any concurrent changes that are happening are protected, right? Because of the use of transactions and other locking mechanisms we have. If you're using the data store, which is sort of the second option, the split cluster mode, we again expose our tables as if they're just data frames. This is no different than any other connector that you might see in the market for other data stores, right? Cassandra would do something similar, right? You can essentially look at a Cassandra table as an RDD of a strong type or as a data frame. But the difference here is that if you're creating essentially so-called column tables, the format in which Spark essentially might cache and manage a column table is exactly the same format we use internally also inside our store. And that is the one reason we get this huge throughput benefit, right? So even if you're operating like this and you're storing and ingesting data, I'll show you later on some performance charts, you get this huge benefit, right? And there's a project called Apache Arrow, which has a similar aim and purpose in mind, saying, hey, if I'm trying to work with column-oriented stores and I'm doing exchanges of data, can I make that significantly more efficient than what is happening today?